This video will be recording my first assignment of my SCH3O course, and this video will be discussing the trend of atomic radius, ionization energy, especially the first ionization energy, and the electron affinity trend inside a periodic table, which means we need to go through the three concepts by applying examples through period and groups. And for each concept, I will apply two pair of examples, which is basically 4 elements. So let's get started. The first concept is atomic radius. So firstly, what is atomic radius? It's basically pointing the outer electron shell, the distance between outer electron shell and the nucleus. So this is the radius. And the atomic radius was mainly determined by two things. First is the electron nuclear charge. So the first thing that could affect atomic radius is the effective nuclear charge, which is basically the number of protons inside a nucleus. And secondly is shielding, which is basically the number of electron shells between nucleus and the outer electron shell. So inside a period of a periodic table, the difference between different elements is the effective nuclear charge, which the higher the effective nuclear charge is, the higher the attraction from the nucleus to the electrons are. So let's take lithium and fluorine as an example first. By comparing these two elements, basically lithium has the higher or the bigger atomic radius. So the reason is that fluorine has more proton number, right? Which leads to it has effective nuclear charge, which protons hold cations, and electron holds anions. There's attraction between protons and electrons in this case. Well, it has higher effective nuclear charge, then it holds more attraction between the outer electrons. So in this case, attraction is disproportional to the radius. So fluorine has the smaller radius. Well, when it comes to a group, let's take lithium and sodium as an example. So as we can see, there's 2 electron shells around lithium, while there's 3 around sodium, which basically points that sodium has higher shielding, which it lowers the attraction between nucleus and electrons. So when attraction is less, then the radius increases because the proton cannot hold the outer electrons anymore. So it flies a little bit farther and it increases the radius. So in this case, sodium has higher atomic radius. So let's go to the second concept, which is ionization energy. So firstly, we need to notice that what is exactly ionization energy? It is the energy required to remove the electrons. So when we're talking about the first ionization energy, we're talking about the energy required to remove the outermost electrons, which these electrons must be placed in the outer shell. So still separated into period and group. For period, the example is still lithium and fluorine. And the reason of explaining this is still by applying the effective nuclear charge. By looking through the graph, we can gain that fluorine obviously have the higher ionizing energy. So what is the reason? Because fluorine has the larger amount of proton number, which it has higher effective nuclear charge, and so there's more attraction between electrons and nucleus. So it lowers the removability of the outermost electrons, that there's more energy required. It's like breaking bonds, right? If you want to break bond, there's energy needed. You need the bond needs to absorb energy. So do the electron shells. You can like understand it in this way. So the energy required is increases as removability decreases. So in this case, the ionization energy also increases. That's why fluorine has the higher ionization energy. And in groups, we can apply lithium and sodium also, which sodium has higher electron shells, which means that it has higher shielding and less attraction because there's longer distance, right? So removability increases, which energy required less. And the first not first. So ionization energy, it's a general term. So let's come to the final concept, which is also the most complex one, and I'm actually not sure that I could explain it clearly to you or not. So first, let's take a look at the definition of electron affinity. It is the energy change that occurs when an electron is added to a neutral atom in a gaseous state. So one thing to notice is it could only be added into a nucleus at an atom state in a gaseous state. So the trend is generally increasing in period from left to right and decreasing in groups from the top to the bottom. So the greater the attraction between, let's take a look at the example first. Still lithium and fluorine for a period and lithium and sodium for a group. So let's take a look at the example between period first. So because fluorine has the higher effective nuclear charge, so it has higher attraction. And by telling you the concept of ionizing energy, it is like to break a bond, right? So it needs to absorb energy. While electron affinity is actually adding electrons, so it's creating an attraction. It's like it's a formation of attraction, which is you can simply equalize it to the forming of a bond. So forming bond releases energy, and so do adding electrons to the outer shell. So when attraction increases, it's harder to release. So energy required, or the energy change, the enthalpy change, also increases. And this leads to that affinity increases because it's indicating the energy change, right? So we can simply summarize like a relation. The greater that the attraction between the atom and the added electron is, the more negative the electron affinity are. So basically, if I'm telling you that electron affinity is more negative, it's basically telling you it's become like bigger. The affinity is bigger. So let's take a look at another example between lithium and sodium. So sodium has higher shielding, so it's the distance is more further apart. So the added electrons and nucleus distance is higher, which leads to less attraction between the nucleus. So at this point, energy decreases. The energy changes, turns lower, turns smaller. So affinity also decreases. So that's all the example part. And let's make a summary. Okay. For atomic radius, it decreases in the same period from left to right, and increases in the group from the top to the bottom, while the ionizing energy increases in a period from left to right, and opposingly, it decreases from top to bottom in a group. And for affinity, it increases in a period from left to right, and also decreases in a group from top to the bottom. And that's all about a video. So affinity is actually hard to explain compared to others because I'm not sure if I can formalize it as, I can treat it as the same as bonding. So adding an electron is basically the process of stabilizing an atom. So the more stable it become, right, the more energy required. So the change of energy is bigger because it turns into more stable state and requires more energy to release. So yeah, I think that's all about affinity because there's not much to say about it and there's no much application about it. Okay, so this is the end of the video. See you next video. Bye bye.